Hi everybody and welcome to topic 3, solving multi-step equations. So what we've been working with so far has been writing equations from words and solving one-step equations. So now what we're going to do is solve an equation that requires more than just one step to get the variable by itself. So if we look at this first example, it's something we know how to do. We've been doing this. In order to solve the one-step equation, you use the opposite operation on both sides. So whatever I do to get rid of that variable that's next to the x, I have to do to the other side as well. So when those cancel out, I get my answer of x equals 13. When we move on to a multi-step equation, we have to think about what term is not attached to the x, or what is the, I'm going to write it over here on the side, non-variable term. So the non-variable term has to come first. What I like to say is that when we use the order of operations, we have our PEMDAS. And when we are evaluating an expression, we work this way. We start with the parentheses, and then we work our way into addition and subtraction last. When we solve, we do just the opposite. So it's kind of like backwards order of operations. We start with the addition and subtraction, then move up to multiplication, division, then take care of the exponents, then take care of the parentheses. I like to think of we're solving, so that's like solving a crime. And when we solve a crime, we always work backwards. So that's one way to remember to use the order of operations backwards. Ooh, I don't know what my pen is doing. That is crazy. I'm trying to write backwards. So we're working backwards. So if we look at our first example, I'm going to do these two u-tries with you guys because this is where it starts. We look for that non-variable term that we talked about over here. We start there. Kind of like through our order of operations, the first thing that we would do would be do any kind of addition or subtraction. So we're going to choose the non-variable term, the one not attached to the variable, and do the opposite operation just like we have been. So when I get that, I am going to get that -4 and the +4 to cancel, so all I'm left with on one side is 3x. 5 plus 4 gives me 9. And we're back to something familiar. We see a one-step equation. We see that we are multiplying 3 times x, so we need to divide by 3. Whatever we do to one side, we do to the other, so I have to divide 9 by 3 as well. So I'm left with x equals +3. If we look at the next example, we have -4x plus 2 equals 10. We want to work backwards through the order of operations, starting with that non-variable term. So the non-variable term in this example is that +2. So the opposite operation would be to subtract 2. When those terms cancel, we are left with -4x equals +8. And then because we are multiplying -4 by x, we must divide by that whole -4. We have to take that negative with us because x is not truly by itself if there's a negative sign in front of it. So we have to divide by the entire coefficient. So those terms now cancel. And 8 divided by -4, we have to be careful with our negatives and positives, is going to be -2. Right, so For more two-step equations, these two are very similar to the last ones we did. We start with that non-variable term by subtracting 5 from both sides. We end up getting 6x equals 17 minus 5, which is 12, and then divide both sides by 6. We are left with x equals a positive 2. The next example is kind of like the very first one we did, where we have a subtracting 7 as our non-variable term where we need to start. So in order to undo that, we use addition. So we get negative 2x equals positive 22. 2 is being multiplied by x, so the opposite operation is division. And again, we need to bring that negative with us because x needs to be alone. The negative 2 and negative 2 cancel, and 22 divided by negative 2 is negative 11. Go ahead and do these two u-tries on your own. Alright, so up at the top we can see that what I've been saying all along we now have in writing. We use the opposite operation to get the variable by itself, but we have to do the addition and subtraction first. Remember, it's backwards PEMDAS. We're solving, so we work backwards to find what x really is. So these ones look a little different than the first two examples, so I will go through these with you. So if we look at number 1, we go to that I'll say NVT, non-variable term, and that is the positive 3. Opposite operation, we need to subtract 3. So those terms can cancel, and we get 5x equals 23 minus 3, which is 20. 5 is being multiplied by x, so the opposite operation is division. The 5's will now cancel, and we get x equals 4 because 20 divided by 5 is 4. Now the second one looks a little different, but that's okay. We still start the same. The non-variable term needs to be taken care of first, which is that positive 12. It's not attached to the d, so we need to get rid of that first. Opposite operation will be subtraction. Once we do that, we're left with negative d over 6. The 12's cancel. 12 minus 12 is 0. And negative 7 minus 12 is negative 19. So now, if we remember from before, when we have a number in the denominator, that means that we're really dividing. So in order to undo division, we need to use multiplication or multiply by the reciprocal. So what we also need to get rid of at the same time is that negative. So I know what's in the denominator is positive 6, but if we multiply both sides by negative 6, we're going to get rid of that negative right here that we don't want next to the d. We just need d to be positive to find out what value it really is. So if we multiply by negative 6, I'm going to put it over 1 because we're multiplying fractions, we can get the negative times a negative is going to give us a positive number, which is what we wanted. The 6's cancel out, so I'm left with just d, which is exactly what I wanted. On the other side, we have negative 19 times negative 6, which is 114. Negative times a negative is a positive. So remember, multiplying by the reciprocal or seeing that it is division, that the opposite operation is multiplication. Last example that I'm going to do with you guys is the third one. We can see that the minus 3 is our non-variable term. Variable term. And so we're going to add it because we're subtracting and the opposite operation is addition. So what we're left with is still that 3/5 being multiplied by x. Negative 3 and positive 3 cancel. 6 plus 3 is equal to 9. Now here's where what we did in number 2, we multiplied by the reciprocal. We're going to do that same thing to cancel out the fraction. So the reciprocal of 3/5 is 5/3. So we need to multiply the right side also by 5/3. Any number times its reciprocal is 1, as we talked about when we did the multiplicative identity. So all of those are on the left side are going to cancel out, and we'll just be left with our x. Now when we multiply 9 times 5/3, I'm going to put 9/1 so we can see that 9 is in the numerator. If we look diagonally, we can see that 9 and 3 are both divisible by 3, so I'm going to go ahead and divide both of them by 3. 9 divided by 3 is 3, 3 divided by 3 is 1. So now I have 1 across the denominator, which is great, and so I go across the numerator. 3 times 5 is 15/1, or just 15. Go ahead and do the U-tries, and we will see you tomorrow in class.